In order to understand how to convert metric prefixes in the metric system, in other words, different sizes from one to another, I think it's really useful to look at dollars because in the United States, US money follows the base 10 system, and it would be much easier to consider money first. So imagine that as a base unit, we had a $1 bill, and $10 would be called a decadollar because deca means 10. $100 would be called a hectodollar because 100 means, or hecto means 100. And if you go smaller, a hundredth of a dollar is a dime. I'm sorry, a tenth of a dollar is a dime, and a hundredth of a dollar is a penny. So I'm using metric prefixes at the top to represent dollars in the middle, and then at the bottom is just the decimal equivalent of that amount. Notice that as we move to the right, the value or the size of the bill decreases by a factor of 10. We divide by 10 as we go to the right for representing the value of each item. But if you were going to look at amounts of money, how much amount of how many dimes would you need to make $100? How many pennies would you need to make $100? You're really asking a different question, not just how much is one penny worth, but how many pennies would you need to make $100? It's a different question. There you have to multiply the value of each bill by the number of bills it takes to make $100. For example, here I've got $100. I'd only need one of those to make $100. So 1 times 100 equals 10 groups of $10 bills, equals 100 groups of $1 bills, equals 1,000 groups of dimes, equals 10,000 groups of pennies. So this is really important to look at the number in front of the value, because this is where it connects to the metric system. Notice that the quantity or number of items is increasing by a factor of 10 as we move to the right when we have equal totals. So we have equal totals here. These totals all are the same, $100, but 1 multiplied by 10 gives us 10. 10 multiplied by 10 again gives us 100. 100 multiplied by 10 gives us 1,000, and 1,000 times 10 is 10,000. So get that out of the way. So here, well, wait a minute. That is not there. Okay. So here we're multiplying by 10 as you go to the right to get the number of items. Going backwards to the left, we would be dividing by 10 as we go to the left. Divide by 10, divide by 10. So as we have larger bills, we'll have smaller numbers in front of them. As the value gets smaller, pennies are real cheap, we need lots of them in order to equal the $100 bill. So a few big things equals a lot of little things. And you can check your numbers that way when you're doing conversions in the metric system. Always be thinking that. Do you have a small number of large sizes, 1 times 100, equaling a large number, 10,000, of little tiny things? If you do, then you probably converted it correctly. It's possible to accidentally be multiplying by 10 when we should be dividing by 10, or just going the wrong direction with our decimal movements, and we end up with the opposite, and that would not be a good idea to say a lot of large things equals a few small things. That would not make sense. So this is just showing how dollars then can be converted into the metric system idea, where here we have a prefix for 100 and a prefix for 10, the base unit, prefix for a tenth, and prefix for a hundredth. In the metric system, there are a lot of prefixes. The ones we commonly use are, well, in science class in 8th grade, for example, we might use kilo, hecto, deca, all the way down to milli. When you do more microscopic work, you'll get micro and microns. And then if you do particle physics, you'll get down to the nanometer and, well, even smaller than that. And then for the larger sizes with computer science, we get kilo, mega, giga, terabytes, trillion bytes, that sort of thing. So notice that the exponents are given here, the exponential form, and we go down, there's a pattern here. So from here, 3, 2, 1, 0, negative 1, negative 2, negative 3, that's going one factor of 10. But then here we're jumping down to the micro, the nano, the pico, those are going by 3. And mega, giga, and tera are differing also by a factor of 10 to the third power, or 1,000. So you notice there is a pattern going on here. So we're going to practice converting. And here we have centimeters converting into meters. 400 centimeters. So what we'll do is we'll say, I've got centimeters, and I want to go to m. Well, what is m? M is here, and m is there. Which m are we talking about? Well, to figure that out, if it just has one m there, it really does mean meters. If it was referring to millimeters, the prefix here, you would have seen mm together. But we don't have two m's, we don't have a prefix, and then the base unit, meter, we just have plain old one m. So we will go from centi back to meters, and we will divide by 10 as we move to the left, and divide by 10 as we change this, resort our units into larger sizes. And so we're going 400 divided by 10 and then divided by 10. And if you do that, you end up with just 4. There's a shortcut for this. Look for the decimal. Every time you divide by 10, you move the decimal one place to the left. Divide by 10 again, one place to the left, you get 4.0, and that's our answer here. We could put 4.00. 3,500 deciliters equals how many milliliters? Well, here's deci, and again, here's ml, so that means milli. So we're going to multiply by 10, and we'll multiply by 10 again. So if you don't see the decimal, it's on the right. Don't just put it randomly anywhere. It's always on the right if you don't see it. When you multiply by 10, you are multiplying by 10 and moving the decimal to the right one space. Multiply by 10 again, moves the decimal to the right again. And now you have two zeros you can fill in, and you get 350000. Go back and put your comma in there. I would not put a decimal here because it would be creating an artificially significant point that there's exactly 0 and 0. Like mathematically you could put zeros here, but scientifically you should not, because otherwise you're saying you've measured exactly and there's no tenths and there's no hundredths, and we have not done that, so we're just going to leave it like this. Be a little bit careful. Sometimes people think, oh, if I'm multiplying by 10 then I add zeros, and if I'm dividing by 10 I take away zeros. That's not true. Move the decimal. Always be thinking of moving the decimal, and then fill in zeros as needed. Let's do another example. This time we'll do it in blue. Let's say we had 3.75 decigrams and we wanted to convert them into hectograms. Well, here's deci and there's hecto. So I need to go to the left 1, 2, 3 spaces. So I divide by 10 repeatedly, 3 times, and then I move my decimal once, twice, 3 times, plop, put it right there, add 2 zeros in this case, and I get 0 and 0.00375 hectograms. To say it correctly, we'd say 0 and 375 tenths, hundredths, thousandths, ten thousandths, hundred thousandths. 0 and 375 hundred thousandths of a hectogram. And again, that's a very small amount, and that makes sense because hectograms are big sizes. That would equal a larger amount, 3.75, of little tiny decigrams. So let's try another example. Here we'll try a couple with this. Here we're going to convert 5 and 63 hundredths meters into decameters. So here's meters, the basic units, meter, liter, gram. Going back to decameters, we divide by 100, and 10, and so we move the decimal one place to the left. We get 0.563, 0 and 563 thousandths. To convert from kiloliters to decaliters, we go over on the left. We're going to multiply by 10 and then multiply by 10 again. So we take our decimal and move to the right once, twice, and we get 36.0 decaliters. And this kind of got cut off. I think it's 301 centigrams equals how many kilograms? Well, here's centi, and kilo's way over on the left. So we're going to do a lot of dividing. Divide by 10, divide by 10, divide by 10, divide by 10, divide by 10. It was 1, 2, 3, 4, 5 places we move to the left with our decimal. 1, 2, 3, 4, 5, plop. Add the zeros, put the 0 in front, and you get 0 and 0.00301 kilograms. That would be tenths, hundredths, thousandths, ten thousandths, hundred thousandths. We'd call this 0 and 301 hundred thousandths. So, I hope that was useful to you. Remember, you can always pause and rewind if you need to. So hopefully you learned to convert metric prefixes into a smaller size. You'll multiply that quantity by a power of 10. And to convert the metric prefix into a larger size scale, you'll divide the quantity by a power of 10. So rewind, practice again, and good luck. Thanks for listening.